if you want to find the trigonometric ratio of a negative angle, we can use the rule here to help us to get the answer. So let's say I want you to find sine negative 30 degree. So first you have to know if negative 30 degree, it means that it go clockwise here, go this way. This is negative 30. So how about negative 30 degree? How about positive 30 degree? So for positive angle, it go counterclockwise or anti-clockwise. This is positive 30 degree. So some students will get confused when deal with negative angle. So if you want to change it to positive angle, it's actually very easy. What do we need to do here is we change the angle become positive first, and then we add a negative sign in front of it. These rules apply for all except which involve cosine. Cosine negative theta is equal to cosine theta. We do not add a negative sign in front of it. So secant also the same, because secant is 1 over cosine, therefore it will follow the rules for cosine, which means we just ignore the negative sign and change the angle become positive angle. Now let me give you a few more examples so that you understand better how do we use these rules to help us solve the question to get the trigonometric ratio of a negative angle. Now let's say if you want to find cosine, let me use tangent first. If let's say you want to find tangent negative 135 degree, and you want to change it become a positive angle, what do we need to do is first we change the angle become positive angle, next we add a negative sign in front of it. So how about cosecant? Let's say I want to find cosecant negative 150 degree. I want to change it to a positive angle first. Cosecant 150 degree, I already changed it to a positive angle, and don't forget we need to add a negative sign in front of it. But when we deal with cosine and secant, you need to be more careful. For example, if I want you to find cosine negative 135 degree, first we change it to positive angle. That's all. We don't have to add negative in front of it. So cosine 135 degree. That's all. We don't have to add a negative sign. Be careful here. For cosine and secant, we do not add a negative sign. We just ignore the negative sign here. The secant also the same thing. Let's say I want you to find secant negative 330 degree. What do we need to do here is just ignore the negative sign. So it becomes secant 330 degree. Now let me use calculator to show you the left hand side here is actually equal to the right hand side here. Let me show this one first. Sine negative 30 degree. You don't have to key in the degree sign, okay, because you see a D over here, right? It means degree. Your calculator already set in degree mode. So when you key in negative 30, your calculator actually know that this is negative 30 degree. Okay. So I'm going to take the left hand side divided by the right hand side. If the calculator gives me 1, it means that the left hand side and right hand side is actually equal to each other. This means that we did it correctly. Okay. Negative sine 30 degree is equal to 1. How about tangent? Tangent negative 135 degree divided by negative tangent 135 degree. We change the angle become positive and we add a negative sign in front of it, equal to 1. So how about this one? So this will be a little bit complicated because cosine is actually this is cosecant 1 over sine. So I'm going to show you this way. 1 over sine negative 150 degree, okay, divided by add a negative sign in front of it. Let me put a parenthesis. If you don't want to put a parenthesis, okay, your calculator know how to calculate it. But when we write, we need to put a parenthesis. Okay, negative 1 over sine 150 degree is equal to 1. Okay, so for cosine and secant, you need to be more careful. We don't have to add a negative sign in front of it. What do we need to do? Just ignore about the negative sign and change the angle, become positive angle. Now, cosine negative 135 degree divided by cosine 135 degree. We do not add a negative sign in front of it. Is equal to 1. Okay, last one. 1 over cos secant is 1 over cosine, right? Okay, 1 over cos negative 330 degree divided by 1 over cosine. Ignore about the negative sign, and we do not add a negative sign in front of it. 330 degree is equal to 1. Okay, so just be more careful. If you want to change the negative angle become positive angle, we can do it like this. Change this negative angle become positive angle, and we add a negative sign in front of it, except for the cosine and secant. For cosine and secant, we don't have to do so. We just change the angle become a positive angle like what we did just now, and we don't have to add a negative sign in front of it. Okay, so be careful for this too. For the rest, we change the angle become a positive angle, and we add a negative sign in front of it. So later on, I'm going to show you how do we use these rules to help us solve some question which involve a negative angle. Okay, the next thing I want to share with you in this video is this one. Let's say if we want to find sine 40 degree. Sine 40 degree is actually equal to cosine 50 degree. How do we know this? So we are using this root. So sine 40 degree is actually equal to cosine 90 degree minus 40 degree. Therefore, it's actually equal to cosine 50 degree. Okay, so here you need to remember sine and cosine one group, and tangent cotangent one group, secant cosecant one group. What do I mean by this? Try to observe the diagram here. Let me make it become larger. Sine theta is equal to cosine 90 degree minus theta. Sine cosine one group, right? Cosine theta is equal to sine 90 degree minus theta. Secant cosecant one group, you see, secant theta is equal to cosecant 90 degree minus theta. Same thing here, cosecant theta is equal to secant 90 degree minus theta. And tangent cotangent one group. Okay, let me show you why it's like this. Now let's look at this diagram. The sum of the interior angle of a triangle will be always equal to 180 degree, right? So here, this is a right angle triangle, this is 90 degree. So these two angles sum up together must be equal to 90 degree. If this is theta, this will be 90 degree minus theta, right? Now, sine theta is equal to, I hope that you still remember this, Dwa Castle. Sine is equal to opposite side divided by the hypotenuse. Opposite side divided by the hypotenuse. Right? So how about cosine 90 degree minus theta? Cosine 90 degree minus theta. So now we are talking about this angle. CAH. Adjacent side divided by the hypotenuse. Adjacent side divided by the hypotenuse. You see? They are equal to each other. Let me show you one more. Tangent and cotangent. So the rest, if you want to test it yourself, you can try it one by one. Tangent theta is equal to TOA, opposite divided by adjacent. this angle. Theta is over here. TOA, opposite divided by adjacent. So how about cotangent 90 degree minus theta? Cotangent 90 degree minus theta is equal to 1 over tangent 90 degree minus theta, right? Now, let's focus on this angle. DOA, opposite over adjacent. Opposite over adjacent. So this is 1 over m over n, which is equal to n over m. You see, they are equal to each other. So remember, sine, cosine one group, tangent, cotangent one group, secant, cosecant one group. So if you always forget about this one, you can use a hexagon to help you to remember it. Okay, this hexagon actually can be used to help us to remember a lot of things, but here I'm only going to talk about this one first. So first, draw a regular hexagon, and then we make a connect like this. Okay, write 1 over here. So remember, tangent is equal to sine over cos, right? So opposite sine will be cosecant 1 over sine. Just remember like this. Opposite sine 1 over sine will be cosecant. Opposite cos 1 over cos will be secant. Opposite tangent 1 over tangent will be cotangent. So this one can help us to remember this. Sine, cosine one group, right? Tangent, cotangent one group, and then the last one will be secant, cosecant one group. So if you don't want to use this hexagon, it's okay as long as you can remember it well. So remember, let me tell it again: sine, cosine. Let me repeat again: sine, cosine one group, secant, cosecant one group, and tangent, cotangent one group. Now, let's try some examples so that you understand how do we use these all rules better. Okay, now let me make this one smaller. Okay, I think this one I just delete it. Let me make the quotient larger. Okay, now given that tangent 47 degrees is equal to h, we don't know what is h. If you want to calculate, you can just press the calculator. Okay, tangent 47 degrees is equal to h, and cosine 47 degrees is equal to k. Find the value of each of the following trigonometric function in terms of h and or k. So this is 47, but why the question is asking 43 degree, which the trigonometric ratio which involve 43 degree. What is the relationship between 43 degree and 47 degree? Try to think. They are complementary angle, right? 47 plus 43 is equal to 90 degree. So it means we can use these rules to help us to solve all this question. Cosine, cotangent 43 degree. We don't have cotangent 43 degree, but we can change it to 47 degree. How do we change to 47 degree? Remember, sine, cosine, one group, secant, cosecant, one group, tangent, cotangent, one group. So this is cotangent. Let me change to tangent, and then it will be 90 degree minus 43 degree. And this will give a tangent 47 degree. Do we have tangent 47 degree? Yes, given by the quotient is equal to h. Okay, this is the answer. So how about part B? Sine 43 degree. Again, this is 43 degree, not 47 degree. But we can change to 47 degree by changing this sign become cosine. 90 degree minus 43 degree. So this is this. Sine theta is equal to cosine 90 degree minus theta. So this is cosine 47 degree. Do we have cosine 47 degree? Yes, which is equal to k. Okay, how about secant? Let me write over here. secant, cosecant one group. So let me change to cosecant, and the angle will become 90 degree minus 43 degree. So eventually it will equal to cosecant 47 degree, and it is equal to 1 over sine 47 degree. But now we have a problem. We don't have sine 47 degree. We only have tangent 47 degree and cosine 47 degree. How do we get sine 47 degree? Still remember, sine is equal, tangent is equal to sine over cosine, right? So tangent 47 degree is equal to sine 47 degree over cosine 47 degree. So remember, tangent is equal to sine over cosine. So tangent 47 degree given by the quotient is equal to h. Sine 47 degree we don't know, we want to find about it. And this cosine 47 degree is equal to k. From here we know that sine 47 degree is equal to hk. Now what do we need to do is just plug in the hk over here. Okay, is equal to 1 over hk. This is the final answer for part C. Now let's look at the second question that I want to discuss with you. Given x is an acute angle, it means that in the first quadrant, greater than 0 degree, less than 90 degree. And cosine x is equal to 1 over q. Express each of the following trigonometric function in terms of q. You want to find secant x, cotangent x, cosecant x, and so on. So for this question, first, you just sketch a diagram first. Draw a diagram. This is acute angle. So it means in the first quadrant, draw a triangle like this, and this is x. Cosine is equal to adjacent side divided by hypotenuse CAH, right? So 1 over q is equal to, so this cosine x is equal to 1 over q. It means that this is 1, this is q. So this one you need to remember it. Cosine is equal to adjacent over hypotenuse. Adjacent over hypotenuse. So this will be 1, this will be q. So how do we get this? We can use Pythagorean theorem to help us get the length for this side, right? So remember what I told before, for a right angle triangle, 2 short, 1 long. If you want to find the length for the shorter side, we use minus. If you want to find the length for the longest side, we just plus. What do I mean here is like this. Let's say this is A, this is B, this is C. If I want to find the length for C, A squared plus B squared, and we need to square it. If let's say I want to find the length for A, shorter side, right? So minus C squared minus B squared, square it. If I want to find the length for B, shorter side, right? Want to find the length for short side, minus, for a long side, plus. Okay, C squared minus A squared square root. So now we can apply these rules on this situation, in this situation. So this side is equal to short side, right? Shorter side, right? So I'm going to use minus q squared minus 1 squared. 1 squared is equal to 1. You don't have to write square, it's okay. Square root of it. So this is equal to square root q squared minus 1. Once you have drawn this diagram, so it will be very easy for we to get the answer for all of this. Secant x, 1 over cosine x, right? 1 over cosine x is equal to 1 over q. 1 over 1 over q is equal to 1 divided by 1 over q, right? In the exam, you actually don't have to write this step. This step is just for explanation, so that you understand better how this will change become q. So 1, copy, divide, you can change to multiply, and we flip over the numerator and denominator. So you remember this? So eventually, this is actually equal to q. Okay, now let's go to part B. Cotangent x is equal to 1 over tangent x. 1 over tangent x, just refer to this diagram, TOA, opposite divided by adjacent. Opposite divided by adjacent divided by 1, you don't have to write the 1, it's okay. So this is the answer for part B. Now let's go to part C. Cosecant x. Cosecant 1 over sine. 1 over sine. Opposite divided by hypotenuse. Opposite hypotenuse. So it will be square root of q square minus 1 divided by hypotenuse. 1 divided by this is actually equal to q over square root of q minus 1. Okay, this is the answer for part C. So if you cannot go from this step to this step, we can actually add few more extra steps so that you understand better. Let me show you clearly. So as what I did here, 1 over this is equal to 1 divided by q square minus 1, square root of q square minus 1 over q. And we change it to multiply, and we flip over the numerator and denominator. But in the exam, you actually don't have to write this. From here, you can straight away go to the final answer. So it's actually equal to q over square root of q square minus 1. Okay, this is the answer for part C. Now let's go to this. Okay, we are going to use these rules again. Remember, sine, cosine one group, tangent, cotangent one group, secant, cosecant one group. Sine 90 degree minus x is actually equal to cosine x, right? So cosine x is equal to 1 over q. So how about this part E? Tangent 90 degree minus x is equal to cotangent x. If you forget, you can just refer to this one. Tangent, cotangent one group, sine, cosine one group, and secant, cosecant one group. Okay, cotangent x is equal to 1 over, or you can just copy the answer for part B, because this is cotangent x, 1 over tangent x. 1 over tangent x, TOA. Divided by 1, you don't have to write 1, it's okay. Okay, this is part E. Let's go to the last one, which is F. Cosine 90 degree minus x. Cosine and sine one group, we change to sine, and this is x. Sine x as OH. Opposite side divided by hypotenuse. Okay, this is the answer for F. Now let's look at this example. Given that sine alpha is equal to 8 over 15, and given alpha is greater than 90 degree, less than 180 degree, it means that in the second quadrant, sketch the corresponding reference angle for alpha, hence find the value of each of the following trigonometric function without using a calculator. Okay, now let me sketch a diagram first. Same thing, draw a cross like this. And this is the second quadrant, right? Greater than 90 degree, less than 180 degree. I'm going to draw a triangle over here. And the alpha is actually over here. 90 degree. Sine, SOH. Opposite over hypotenuse. Opposite over hypotenuse. So as we did just now, we want to find the length here because definitely later we need to use this one. So again, use Pythagorean theorem to help us to find the length here. But you have to be more careful because this is left hand side of the y-axis, right? So we need to add a negative sign. Okay, how to find this? Shorter side minus 15 square minus 8 square square root. Okay, let me use my calculator. 15 square minus 8 square is equal to 161. So this is square root of 161. And don't forget to add a negative. Why do we add a negative? Because this is left hand side, right? So this is negative. So if for okay, this is Cartesian plane y x. Here is positive 1 2. This is positive 1 2. Here is negative -1, -2. Here also same negative -1, -2. That's why go this side, we add a negative sign for it. Okay. For hypotenuse, we always write a positive number. Now, let's try the first part. Okay, just now I told you that for hypotenuse always positive, right? So what do I mean by this? Let me give you another situation. Let's say sine alpha is sine alpha. Let me check. Sine alpha. Okay, let's say sine alpha is equal to -1/2, and given by the question, alpha is greater than 180 degree and less than 207 degree. So we know that this is in the third quadrant, right? So how do we sketch this diagram? Draw it under here, draw a triangle, and this is alpha. So how do we fill in the number here? SOH, opposite over hypotenuse, opposite over hypotenuse, but you see a negative sign. The problem is, how do we fill the negative? So we have to put -1 or -2. So remember what I told just now, for hypotenuse always will be positive. So in this situation, go downward like this, right? So we are going to add a negative over here. Okay, so how about to find the length here? Let's say you want to find the length here. This is shorter side, minus 2 square minus. If you don't want to write -1 square, you write 1 square. It's the same thing, right? Okay, square root, because 1 square is equal to -1 square. They both give you exactly the same result. Okay, this is 4 and this is 1. 4 minus 1 is equal to 3. Square root of 3. But is this correct, this diagram? No, this diagram is not correct. Go left hand side, don't forget to add a negative sign. Okay, this is the way how do we sketch this type of diagram to help us solve the question. Okay, let me just erase this one, go back to our questions. Find the value of each of the following trigonometric function without using a calculator. So we have drawn this diagram. So we can just use this diagram to help us to get the answer for all of this. Cosine alpha, CAH. Adjacent over hypotenuse. Adjacent over hypotenuse. Okay, this is answer for part A. Now let's go to part B. Tangent alpha. TOA. Opposite over adjacent. TOA. So the negative sign for your final answer, if you have a fraction for a final answer, and this is a negative fraction, don't write the negative sign in front of the denominator. So write in the middle or in front of the numerator. But normally we will prefer to write in the middle of the fraction. Okay, TOA, OA. Okay, this is the answer for part B. Now let's go to part C. Cosecant alpha. This is 1 over sine alpha. Okay, 1 over sine. Sine is given by the question. We don't have to refer this diagram, just copy this one. 8 over 15 and 1 over 8 over 15 is actually equal to 15 over 8. Okay, this is the answer for part C. Now let's go to part D. Secant alpha, 1 over cosine alpha. Okay, Now just refer to this diagram, CAH, adjacent over hypotenuse. 1 over this will become 15 over square root of 161. And don't forget the negative sign. Okay, now let's go to the last one. Okay, this time we involve negative angle. Still remember what I told you just now? How do we change the negative angle to positive angle? First, we change the angle become positive, and then we add a negative sign in front of it. This applies for all except for cosine and secant. Okay, secant is 1 over cos, so we will follow the rule for cosine. For cosine and secant, we just ignore the negative sign, change to a positive angle. The rest, we change to a positive angle and we add a negative sign in front of it. Now, let's go to this one, cotangent negative alpha. I don't have negative alpha, I only have alpha, but it's okay. We can change this negative alpha to alpha. For cosine, for cotangent, change the angle, become positive angle, and don't forget to add a negative sign in front of it. If this is cosine or secant, we just change it become positive angle. We don't have to add a negative sign. Okay, so be careful. Let me repeat again. For cosine and secant, we don't have to add a negative sign in front of it. For the rest, we need to add a negative sign in front of it. Okay. Now, 1 over tangent alpha, negative 1 over tangent alpha. Just refer to the diagram that we drew just now. TOA. TOA, and don't forget the negative sign. Since here we have negative, here we have a negative, it will become positive, and the answer will become square root of 161 divided by 8. Okay, this is final answer for E. Okay, this is the last question that I want to discuss with you in this video. Okay, without using a calculator, find the value of each of the following trigonometric function. So if without using a calculator, it means that this will involve a special angle, 45 degree, 30 degree, 60 degree. So which we can use this triangle to help us to get the answer. Okay, before solving this, we need to know ASTC. What does this mean? It means that in the first quadrant, all positive. In the second quadrant, only sign positive, and definitely cosecant will be positive as well, because cosecant is equal to 1 over sine. It will follow the rules for sine. So in the third quadrant, only tangent positive, and cotangent will be positive as well, because cotangent follow the rules for tangent. In the last quadrant, cosine positive, and secant will be positive as well, because secant is equal to 1 over cos. So remember this ASTC, which you learn in modern math as well. Okay, cosine 225 degree. So first we need to know which quadrant this angle lies in. Now let me just draw a cross for you. This is 225 degree, so it's somewhere around here. This is 225 degree. First, we need to know the reference angle. This is a reference angle. It's an angle between the line where the angle stops and the x-axis. Remember, x-axis. The angle between the line where the angle stops and the x-axis. So always measure with the x-axis. Okay, be careful. So how do we get this angle? So we can just take 225 minus 180, right? So we will get the angle here. So 225 minus 225 degree minus 180 degree. Okay, we get the reference angle and add a cosine in front of it. And then we need to think, should we add a negative sign in front of this, which we can determine by using these rules ASTC. This is third quadrant. Third quadrant's tangent positive, cosine negative. Okay, now negative 45, negative cosine 45 degree. The negative we just copy. Cosine 45 degree, you can use a calculator, but since the question tells us without using a calculator, so we need to use this triangle. So remember this two triangle. CAH 1 over square root of 2. Okay, this is a way how we get this answer. So let me repeat again the process. First, sketch a diagram. Determine which quadrant the angle lies on, and then find the reference angle. Then use the rules ASTC to determine whether we should add a negative in front of it. Now, let's try part B. We're still using the same process. Sine 150 degree. Okay. Same thing, draw a cross. 150 degree is somewhere over here. This is 150 degree. So how to determine the reference angle? The reference angle is the angle between the line and the x-axis, which is over here. How do we get this angle? I think it should be no problem, right? 180 degree minus 150 degree, then you will get the angle here. Okay, which is equal to 30 degree. So this is sine 30 degree. Next step, should we add a negative sign? A, S, T, C. This quadrant sign positive, right? So we don't have to add a negative sign. Just keep it like this. Then just refer to this triangle as OH 1 over 2. So if you want to double check, you can press the calculator. Sine 150 degree is equal to 1 over 2. Let's go to part C. Tangent 315 degree. Okay, first draw the angle, sketch a diagram as we did just now. 315 degrees somewhere over here. Stop here. Third quadrant. So this is 315 degree. How do we get the reference angle, which is over here? We take 360 degree minus 315 degree, which will give you 45 degree. So I will change it to tangent 45 degree. This is reference angle. Okay, the reference angle will be always equal to an acute angle. Okay, next step. Should we add a negative sign? According to the ASTC, in this quadrant, only cosine positive, right? Now we are talking about tangent. We need to add a negative sign. Then copy the negative sign. Just refer to the diagram. TOA. Tangent 45 degree is equal to 1 over 1, which is equal to 1. And this is negative 1. So you can check by pressing your calculator. Tangent 315 is equal to negative 1. Now let's go to part D, this time which involve a negative angle. But no problem, right? You know how to change a negative angle become a positive angle, right? What we did just now. Okay, cosecant negative 210 degree. This one I think it should be no problem, right? We did just now. First, I'm going to change this one become 1 over sine negative 210 degree. Next, I'm going to change the negative angle become positive angle. Okay, change the negative angle become a positive angle and add a negative sign in front of it. Except for the sine, except for the cosine and secant. Cosine and secant, we don't have to add a negative sign. The rest we need to do so. Okay, now let me continue over here. 1 over. Okay, this I just copy. Now I want to determine about this one. What is the value for sine 210 degree? So sketch diagram, 210 degree. What is a co-reference? What is the reference angle? This is 30 degree, right? How do we get 30 degree? 210 minus 180, which is equal to 30 degree. Okay. Now, sine 30 degree. Next step, should we add a negative sign? Yes. In this quadrant, only tangent positive. Now we are talking about sine. We add a negative sign. Okay. Negative will become positive. So ignore about these two negative because it will negative, it will become positive. Now we only need to deal with the sine 30 degree. Sine 30 degree as OH, opposite divided by hypotenuse. Okay, the final answer will be equal to 2. Okay, for part E, I will let you try yourself. I give you the answer. Secant 135 degree is actually equal to, the answer is negative square root of 2. You just do as what we did just now. I think it should be no problem to get this answer. Okay, next let's go to this trigonometric function, but this time the angle is given in radian. When you see pi like this, it means that this angle is given. This is in the unit of radian. It means 4/7/4 pi radian. So if this angle given in radian will make you confused, you can actually change it to degree first. So later on, I will show you change it to degree first, and then just do what we did just now. Pi radian is equal to 180 degree. So this pi is just 3.14 something, right? So from 3.14 something to 180, you know that if you want to change radian to degree, the number will become larger. Degree to radian, the number will become smaller. So radian to degree, number become bigger, so the bigger number on the top, small number at the bottom. Degree to radian, number becomes smaller number on the top, larger number at the bottom. Okay, now let me show you this one. 7/4 pi. So if I want you, if let's say I ask you to do so, if the pi will make you confused, you can change the degree. If you don't want to change degree, you can do it like this. It's okay. You don't have to change the degree. Okay, 4/7 pi. According to this is in radian. You want to change the degree, then it will become 7/4 pi times 180/pi. So this is in radian. Let me write radian over here. Okay, so what you notice here is the pi will actually cancel out each other. So at the end, we only left this 180 and 7/4, right? So later on, I'm going to do it faster. Whenever you see the angle in pi, in terms of pi, in the unit of radian, you can just assume the pi as 180. You just take 7/4 times 180. You get the angle in degree. 5/3 times 180. You get the angle in degree. Negative 8/3 times 180 degree. Y times 180 degree is actually times 180 divided by pi, and we cancel out the pi. Eventually, we only left 180 degree. Okay. Now, let me show you here. F cotangent 7/4 pi. Cotangent 7/4 pi. Normally in this situation, if the angle is given in terms of pi, we know that this is radian. The question will not write the radian here, but we need to know this is actually in radian. Okay, so as I told you now, how do we convert it to degree? A faster way, we just assume the pi is 180. Just press your calculator, 7/4 times 180. So you get 315 degree. Okay, so the next step is just do as what we did just now. 1 over tangent 315 degree. Sketch the diagram. 315 degrees over here. What is a reference angle? The reference angle is over here. How do we get this angle? We take 360 minus 315, which will give you 45 degree. Okay. Right tangent 45 degree. And don't forget, next step, you need to think, should we add a negative sign? According to the ASTC, in this quadrant, cosine is positive, the rest will be negative, right? Now we are talking about tangent, therefore we need to add a negative sign. Okay, copy this one and use this triangle to have us get tangent 45 degree, TOA, which is equal to 1. So the final answer is -1. Okay, this is F. For part G, I let you try yourself. Part G, the answer, you should be able to get -2 over square root of 3. Okay, correct. So let me show you part H. Now this time, this is in radian and we have a negative sign. Second, -8 over 3 pi. So I'm going to convert it to degree first. So how do we convert it to degree? You just assume the pi is 180 and you key in your calculator 8 over 3. Let me show you here. 8 over 3 times 180. You get 480. -480 degree. So this is equal to 1 over cosine -480 degree. So next step, I'm going to change this negative angle become positive angle as we did just now using these rules. So still remember, we change the angle become positive and then we add a negative sign in front of it. But for cosine and secant, we don't have to add a negative sign. Okay, just change the angle become positive angle. Until here, I think it should be no problem to get the answer right. Sketch the angle, determine which quadrant the angle lies on, and then use the ASTC rules to help us to determine whether we need to add a negative sign for it. Okay, 480. One round will be 360. We need another 120. Okay, so this is 480 degree. The reference angle will be over here. Always measure with the x-axis. So this is 120, right? 360 plus 120. It means here is 60 degree. Okay. 1 over cosine 60 degree. And then we need to think, should we add a negative sign? According to the ASTC, this is sine, right? Now we are talking about cos, so we need to add a negative sign. Negative right in the middle of the fraction. Cosine 60, use this triangle to help us to get the answer. CAH, adjacent divided by hypotenuse. So eventually we will get -2. Okay, so this is the answer for H. Okay, for J, for I and J, I let you try yourself. These are the answer. Let me show you one last one. Cotangent -2 over pi radian. Okay, let's say you don't want to convert it to degree. You can actually do it like this. Also, you will still get the same answer. Now, cotangent -2 over 3 pi. You don't have to write the radian. Whenever you write pi like this, people know that this angle is in radian. 1 over tangent -2 over 3 pi. So now I'm going to change the negative angle become positive angle. Still remember, we change the angle become positive, add a negative sign in front of it. But for cosine and secant, we don't have to add a negative sign in front of it. Add a negative sign, change it to positive angle. So if you want to change it to degree, yes, you can do so. If let's say you don't want to change the degree, you want to keep it in radian, no problem. Okay, still the same thing, we need to sketch the diagram. We need to determine which quadrant the angle lies on. So this is 2/3 pi. So like this is pi radian, right? Pi is equal to 180 degrees. So this is less than pi. This is less than 1 pi, but more than pi over 2. This is pi over 2, which means 90 degrees. So we know that this angle is over here. This is 2/3 pi. And the reference angle is 180 degrees pi, right? So pi minus 2/3 pi, it means 1 pi minus 2/3 pi. It will be pi over 3. Okay, now let me copy the negative, write the negative in the middle of the fraction. 1 over tangent pi over 3. And if you remember what I told just now, you can get the angle easily. Pi over 3, you just see the pi is 180 degrees. 180 degrees divided by 3, which is equal to 60 degrees. So we are going to use this one, this triangle, to help us get the answer. Okay, now we already changed it to reference angle. Next thing we need to think, should we add a negative? Yes, this is sine, right? This is in the quadrant of sine. Sine positive, the rest will be negative. So this is negative. Let me put a parenthesis here so that you won't confuse with these two negative signs. This negative sign we copy from here. This negative sign is from the ASTC part, because this is tangent, but in the second quadrant, sine positive, tangent will be negative. Therefore, we add a negative over here. Negative, negative eventually become positive. So now we left 1 over tangent pi over 3. So pi over 3 is equal to 60 degrees. So look at this one, TOA over 1. So you don't have to write 1. So the final answer is 1 over square root of 3. Okay, that's all for this video. See you in the next video. Bye bye.